at the end. So what we're going to look at is just hypothesis testing for means and proportions of single samples today. Those will be going on to chapter, they're going on through, we'll have to do multiple samples at some point, but right now we're just going to look at single samples. So let's say, let's say somebody makes a statement, somebody makes a claim. Somebody like Danford says that the average age of a institute student is 22. This is a claim that he makes. So he says the average age of an institute student is 22 years. So this statement he makes right here in the class, right? So there's nothing egregious about it. There's nothing contentious about it, I would imagine. So nobody's really going to challenge this claim. Hopefully, nobody's going to say that is it really a 22, or is it more than that or less than that? So let's say that for the sake of argument for this particular part of the class, nobody challenges that, and that's just the claim. We know, if we remember back from chapter 4, when we first started talking about probability, every single outcome of any event has to fall within a sample set, right? That means that everything belongs to some distribution of some set. And if there is one claim like this, there has to be associated with it another claim that makes up the complete set of all possible outcomes. Because he said that the average age of an institute student is 22 years. So either he's going to be right, he's going to be wrong, right? It can't be both. He can't be both. He has to be either right or wrong. So let's just say this is right, that he is in fact correct, and the average age of an institute student is 22. If he were wrong, the only possibility for describing an event that makes him wrong would be just the opposite of this, right? Where the average age of an institute student is not 22. So, given these two possible outcomes that are associated with the same set of possibilities, one of them has to be true and one of them has to be false, right? Because in this case, let's say you go out and you sample a group of students and you find that from that sample of students, those students are in fact 22 on average. One might be 24, one might be 20, but the average is 22. Okay? So that means that this statement would be correct. If you went out and you found that the average of the students was, let's say, 25, then this statement would be wrong. So the bottom one would be correct. So if you look at this, if you look at both of these statements in conjunction with each other, meaning that one of them has to be true and the other one has to be false, then the two of them together must make up 100% of all the possible outcomes from this event. Somebody chosen at random is going to fall in one of those two categories. Any group chosen at random is going to fall in one of those two categories. Has to be, right? When we start looking at this area of hypothesis testing, then we're going to have to define what our hypotheses are. So, for us, we're going to call this statement that he made, that is not being challenged by anybody, right? The null hypothesis. And this null hypothesis, we're going to assume this null hypothesis is true. We're always going to assume this null hypothesis is true unless there is compelling evidence, right, to make it incorrect. So if somebody says something, like he says this, unless we have a strong reason to challenge that, we're just going to assume it's true. Okay? Now, if we go out and we conduct a sample, we conduct a survey, and we find that overwhelmingly, we find that the average age of an institute student is something other than 22, then we will say, oh, well, there's compelling evidence to the contrary, and we may now want to look at whether or not that null hypothesis is in fact true. Otherwise, we will assume it's true. The statement at the bottom that complements the null hypothesis, we're going to call the alternative hypothesis. Okay. And this alternative hypothesis is only going to be true when the null is false. Okay? So, the null hypothesis will always assume to be true unless there's compelling evidence to the contrary. The alternative hypothesis will always be true. Well, sorry, so the alternative hypothesis will only be true whenever the null hypothesis is false. Okay? So, let's look at two other possibilities that he could have said as a part of our world of possible setups for hypotheses. Let's say that he had said, on the other hand, that the average age of an institute student is at least 22 years. Okay? So what would be the alternative hypothesis to this? If he says that the average age of an institute student is at least 22.
The average
Age of an institute student is more than 22 years.
No.
More
He
than
already said
23 years.
is at least 22. The average age of an institute student is at least 22. So what would be the, which is not 22 or less?
Less than 22.
Yeah, it's less than
Because it's not equal.
22. Yes. So, and we'd be a little careful with that too, right? Because if you said 22 or less here, that means if you find out that somebody is 22, then you don't know which one of the categories they fall in, because they can fall in both.
Yeah.
So that violates our rule of mutual exclusivity, right? So first one is at least 22, then the alternative to that then would be less than 22. So again, this would be considered our null and our alternative. So null, alternative. See how both of those together make up 100% of all possible outcomes? Somebody who is 22 or 23 or 24 will fall in this category. Everybody else will fall in this category. Then, now, if we look at the third possibility for setting up HOs and HJs, or nulls and alternatives, he could have said that the average age of an institute student is no more than 22 years, which means that the alternative to this would be what?
more than
More than. It's more than 22 years. So, the null and the alternative. Okay. Now, so that we can start to symbolize these things, to conduct our tests, to start conducting these tests for hypotheses, right? This statement that somebody is making, this claim that is being made by someone, which we're trying to evaluate mathematically. Right? In order for us to start doing that, we're gonna have to start symbolizing these things in such a way that we can evaluate them mathematically. So clearly we're starting out in this overall topic looking at means, right? Hypothesis test for means and proportions. We're not dealing with proportions yet, we're just talking about means. And every statement that we have here is about a mean, right? The average age. Everything is about a mean. So, the average age of a student, the mean age of a student, the average age of a student, the mean age of a student, everything here is about a mean. So, this null hypothesis that we're calling the statement of affairs that is true unless there is compelling evidence to make it false, we're going to symbolize as HO, the null hypothesis, and the alternative hypothesis is simply going to symbolize as HA. So HO and HA, HO and HA. Okay. Now let's look at what he said and try to formulate it in terms of a statement about the mean. So he said the average age of an institute student is 22 years. So what he's making a statement about here is what? The average age of all institute students. No, not any particular group of institute students, but all institute students he's talking about. He didn't say the average age of a stats student at the institute is 22. He didn't say the average age of a management student at the institute is 22. He said that the average age of an institute student is 22. He's talking about all institute students, which means he's making a claim then about the population of institute students. Because he's making a claim about the population, then it means that his statement then is about mu. And this statement about mu is extraordinarily important that we understand that that is about mu. So he says that mu for the institute students is 22. Which would mean then that that the alternative hypothesis would be what? That mu is not equal to 22. And then here, if he had made this statement, the average age of an institute student is at least 22, then he's saying that mu is greater than or equal to 22. And here the alternative, mu is less than 22. And if he had made this statement, he would have said then that mu is less than or equal to 22. And the alternative would be mu is greater than 22. So, for our hypothesis test about means, they are the only three possible setups for the null and alternative hypotheses. There are no other possibilities. Okay? The only thing that could change is the number. But the setup of it has always got to be like that. One of those three things is going to be your choice. Where the stress starts to fall on you is choosing which one. Okay? Because choosing which one is not going to be easy. I'll tell you now, it's not going to be simple. You have to really, and more so than in any other area of this class, you have to really pay attention to every single word that these questions ask you, because every single word is trying to set up a scenario. It's trying to set up what is happening in the background, where these people are, who is making a claim, why is the claim being made. And those things that they're telling you will cause you to make a decision, one way or the other, about a number of things we need to do in the procedure. Okay? So this is not the section to gloss over any word. Every word has to be taken into context when we look at the problem. All right. So let's look at this first one. Okay. Average age of an institute student is 22 years. If we look at HO here, we notice that the equality is in HO, right? The equal sign exists in HO. If we look here, we notice that the equality is in HO. We look here, we notice that the equality is in HO. Every single possibility for the null hypothesis has to include the equality. So what I mean by that is that even if Danford had said this, even if he had said that the average age of an institute student is more than 22, even though he said more than 22, if you remember, we go back to chapter 6. In a normal distribution, you have to tell the normal distribution where this 22 is likely to start. You don't know exactly where it is, but you have to give it a place to start. So even if he had said that the average age is more than 22, you still have to set up HO like that. So that is to say, no matter how you feel, no matter how you want to think that, oh, it said more than, or it said less than. So I'm not going to put the equality sign. That would be an enormous problem. You always want to, no matter what you do, put the equality sign in the null hypothesis. Okay? Otherwise, you're going to have an issue with the distribution. So that's caveat number 1. Okay? So let's look at the first one. What does this mean? That the average age of an institute student is 22 versus the average age of an institute student is not 22. Now this statement is what he said. I know I'm spending a lot of time on this because this is going to be the most difficult part of it. You having to figure these things out. This is what he said. If he's saying this and nobody has any contentious feelings about it, we're not going to try to prove. He doesn't have to prove what he says. That's not the point of the procedure. If he says this and you're okay with it, then he doesn't have to prove this. No proof is necessary. So what we do then, we say, well, even though he doesn't have to prove this, how do we know if he's right or wrong? He doesn't have to prove it. How do we know if he's right or wrong? So, since that's what he said, that the average age is 22, which means that he's saying that, right? That the average age falls on that number, it's 22. That's what he's saying. We'll say, or our procedure is now going to say, all right, since that's what he says, let's not try to prove him right. Let's not try to prove him right. Let's try to prove him wrong. Now there's a huge difference between trying to prove somebody right and trying to prove them wrong. Because we're not saying in our procedure we're going to learn today, let's try to prove that the mean is in fact 22. We're going to say, let's try to prove that the mean is something other than 22. If we prove that the mean is something other than 22, let's say we prove the mean is 24, or we prove the mean is 20, that would automatically mean that he's wrong. So, in this procedure here, when we say we're going to try to prove him wrong, the procedure says, all right, he says the mean is there. So, look on the left-hand side. Is the mean actually here? Yes or no?
No.
Well, we don't know yet. That's what we're trying to prove. Okay, we don't know. But that's the procedure saying, look on the left-hand side, right? Because it says the mean is not 22. He says the mean is 22. We're going to say, well, let's see if the mean is something that's other than 22. So we're going to look on the left-hand side and say, hey, is the mean here? Or, hey, is the mean here? Is it somewhere other than where he said it is? Okay? Because then, the procedure is telling us to look on both sides of the distribution to see if the mean is somewhere other than where he said it was. Then we are going to call this test a two-tailed test for the mean. A two-tailed test for the mean. Why is it a two-tailed test? Because we have to look on both sides to see if the mean falls on one side or the other, but not where he said it was. Okay? Does that make sense? Yeah? Okay. So let's go to the second one then. In the second one, he said that the average age of an institute student is at least 22. So, he's really saying this, right? The average age of an institute student is at least 22. He's saying what? That the average age falls where? To the right. That the average age falls from here to the right. Yeah? He's saying the average age either is from here going someplace over here. It's at least 22. Our procedure says we don't care if he says the average age is 22 or more. If this is what he's saying, we need to try to prove whether or not the mean falls over here. He says it should be here, from here, that way. We say, okay, well if that's what he says, let's see if it's on the other side. If we find it over here, that means that he's wrong.
Right.
If we don't find it over here, then he has to be right. The mean can only be on one side, right? It has to be somewhere. If he says it's over here, and we look over here and we don't see it on this side, then he has to be right. So since he says it's over here, but we're going to look on the other side to see if it's over there, we're going to call this test then a one-tailed test. And which tail? Left tail. So he says, I think it's someplace here to the right. We say, okay, let's test the left-hand side and see if it's there or not. If we find it there, then he can't be right. So, let's look at the last one then. In the last one, just the opposite is the case, eh? He said the average age is 22 or less. So he said the average age is from here, go that way. That's what he said. It's from here, going that way. See all this stuff we learned back in chapters 6 and 7 about directions of these things now come back to culminate in this chapter? He says it's here, that way. So we say, okay, well if he says it's over there, someplace from here go back, let's look over here and see if it's on that side. If we find it over here, then it can't be over there, so he would be wrong. If we don't find it over here, it has to be over there then, and he would be right. So we would then call this one what?
One-tail test to the right.
One-tail test. One-tail test. And right tail. Okay? The reason we are so concerned about where he says the mean is and where we're going to be testing is because the procedure requires us to learn rules about which side of the distribution we're looking on. And as we go through these examples, the examples are going to tell you if he says the mean is on the right, then you need to look on the left, which means you need to test the left-hand side, which means your critical value from the distribution has to be on the left-hand side, right? That value of z that we will be able to find from the distribution has to be on the left-hand side, and so on and so forth. So, as we go through these examples, remember, these are the only three possibilities. The choice of the possibilities is going to be up to you depending on the scenario. And depending on whether or not he said something is equal to a number, greater than or equal to a number, or less than or equal to a number. Those are going to be your choices.
Can you take that off the block?
No, not yet. Now, Helga, this is very straightforward, hopefully. But it doesn't end there. There's some issues. There's some problems with this that we have to look at before we move on, because these problems become very problematic. Right? Now remember when he was in here, Danford was in here, and I said he made this statement, right? And I said he made this statement in here with us. Nobody in here thought that the statement was egregious. Nobody thought there was any contentiousness about this, so it's fine. We're not going to make a big deal about it. There's no reason for us to disbelieve him if he says that. No, at least not for me. That scenario, though, was set up in such a way that we realized that he was amongst friends. Here, we're not going to hassle him. If, however, he made this statement in the media, or if he's giving a speech to a group of people generally, or if he is somewhere out and about and he makes the statement to, let's say, the heads of the Clearing Banks Association, just in some cocktail reception, he makes this statement. He needs to be very careful about making that statement. So because he needs to be very careful about making that statement, he better make sure, before he says that he knows he's right. Nobody with any sense would go in the media and make a statement unless they are sure about what they're saying. Because somebody is going to try to prove it. Somebody is. Whether innocently or maliciously, somebody's going to try to prove it. So, if he says this statement here in the media, we don't care. Because one person is either going to be right or wrong. Either he's going to be right, he's going to be wrong. So we can do nothing with this. But if he makes this statement there in the media, he has to be very careful. He has to make sure that this statement here that he said is true. Because of that, because of this media statement, right? Because of this media statement, we can no longer treat this statement that he made as the null. Because this is not the, remember now, if you remember what I said, you've been listening to what I said. This is not the statement that our procedure is going to try to prove. Our procedure is only going to try to prove the alternative, to see whether or not the alternative is true, to make this statement appear either true or false. But if he makes this statement in the media, this statement now has to be the thing that is tested. This statement has now got to be the thing that is proven. So this statement will end up down here, if it's a media. That would now end up down there, meaning that we would now have to say this instead. His statement will have to be put in the alternative, because we have to now make him prove his statement. Prove it. Or as your book calls it, the Missouri Rule, show me. Show me that you're right. Okay. So what that means, Shakira, is that the scenario around the problem means more to you than just the numbers. You have a choice to make, and only you can make that choice. One of them is right, it's right or wrong. Oh yes, it's right or wrong, but it's your choice. Second problem, the second thing we've got to look out for is whenever somebody makes a statement, and that statement is of what we call extreme directionality, extremes. If we notice here, he only said that the average age of an institute student is at least 22. There's nothing extreme there. He didn't say the average age of an institute student is way more than 22, or is significantly more than 22. There's nothing extreme about this statement. But if he said it's way more than 22, what does he mean? He doesn't mean, oh, it's 22 or a little bit more, right? He's saying now if it's way more than 22, he's saying, oh, it's someplace over here. It's way more than 22. It's in the tail of this distribution. If he says that it's in the tail of this distribution, you need to tell him to prove it. Prove that it's over here. Because if he says, oh, it's at least 22, that means if you're looking at somewhere, you're looking at 22 and somewhere to the right of it. But if he says way more, he's saying over here, so you got to tell him, prove that what you're saying is true. So, if it's extreme directionality, he has to now prove it. So this would then become that. Okay. Another problem that comes up quite often, more so than any other one, is the issues associated with research hypotheses. Research hypotheses are very common because hypothesis testing is used very common in research. A research hypothesis refers to situations where the person conducting the test and the person conducting the research are the same. Let's take a pharmaceutical company, GlaxoSmithKline, Pfizer, Merck, whoever. They conduct clinical trials all the time. All the time. It's a huge part of what they do. That's why they hire mathematicians, because all they do is conduct clinical trials. They're producing new drugs all the time. And these new drugs that are being produced by scientists need to be tested eventually on people. Somebody has to test it to make sure it works. So they go and grab a group of people, 100 people, 1,000 people or whatever, who have the ailment that they're trying to cure. They give them the drug, and then they watch how the other people react to it. I mean, there's no other way. That's how they get the whole list of side effects to tell you this thing might kill you eventually, right? I mean, you see the ads, and the ads are this whole list of side effects, including death, right? And make sure they put that there just in case it happens. You know, liver damage, kidney damage, this damage, that. But your depression will go away, right? But you'll be
It
dead.
could go away because you die.
Right. But when you look at the scenario around the research, right? The pharmaceutical company Merck or whoever is conducting the research. They're conducting the clinical trials. They're the ones who have the data. Nobody outside the company has it. Only them have it. So because they are so intimately involved in everything, there's no way to independently test this. We have to tell them to prove it. Their claim now has to go in the alternative. So these three situations, media, extreme directionality, and research, in those three cases, whatever the claim is, the hypothesis is, the statement is, in those three occasions, the hypothesis that is made will always be put in the alternative. And as long as you remember, only what you put in the alternative is being tested, and these three scenarios are scenarios that require the claim itself to be tested, you'll be fine. Okay? Those are the overarching rules. So let's move on. That's the kind of
Just one
problem.
question, so
Mhm.
these things will be like embedded in the question.
Yes, we're going to do a
Okay.
question right now,
Okay.
and you're going to see.
So we can do that. Can we?
Yes, you don't.
Take that
Yeah,
down,
take it down.
please?
You have it. Yeah, even though all that's in your book.
Yeah, but we like
Mr.
to-
Roll,
I
the
didn't
way you
take
used
that.
to different, you need to do a book.
I didn't.
Change
I
anything.
didn't. I wouldn't say change anything.
Yeah,
but I
but you
didn't.
need to do a book.
That's not my intellectual property. Okay. You know, I'll tell you one thing. You know, I'm not at all opposed to this stuff. You know, taking pictures and all that stuff. But I just want. No, I'm not at all opposed to it. It's great. I just want you all to make sure that it doesn't make you lazy.
No, I'm
No,
not.
I have.
I'm just saying, I just want you to make sure it doesn't make you lazy. Because you've already seen this whole, this whole texting phenomenon, right? This whole texting phenomenon that has made people so lazy that you even notice now in you getting emails at work and people are using these PPL
Yeah.
and you. Just to let it
I
you-
know
Not
why
lazy,
you-
dumb.
Yeah.
It is.
Some people can't even
Our
write
dog
properly
playing.
anymore.
Listen,
They used to teach
not
you
only
to
that,
walk.
if you realize now, I don't know if you guys realize it, but I know
Anymore.
my friends and I, we talk about this all the time, right? Because people today, and I'm saying even to work, people today don't even know when to use the different forms of a word.
No.
There and there.
There and there and here.
Your,
and
there,
there.
your.
All
Like,
of those things
I
are
hate that.
gone.
Yeah.
They are gone.
They post this
serious.
intelligent thing on Facebook,
Be
like
like
this
a
big
customer
statement,
college yesterday.
and it's like, and I'm like, okay.
No, but it's a new company, right? And you're writing me, I'm requesting to do this, and my colleague recommended me. Would you write for college though? So you don't know these
I
other big
hate
words,
it.
but you write in college?
I mean, you could understand. Okay, if someone makes a spelling error,
Yeah.
Yeah, you can tell a
you
spelling
could
error.
understand.
Yeah.
Okay, a spelling
Spell
error.
check.
Yeah, fine, fine. I
but
agree.
yeah.
But
That-
when
Them your and your.
and your, but and the
Your
worst
and
one,
your.
the worst one are the theirs, man.
There.
There.
And
T-H-E-I-R.
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 Oh my
They
god.
nobody knows the difference.
No. No.
It's-
There's a place and one in.
Here, here, and here too.
Here. I tell you, here.
You can meet me here.
Where?
J-I-R.
No.
And where that was it
Yeah.
before?
H-E-I-R.
Where I got like 3 or 4.
What's the other one?
H-E-A-R. H-E.
You
H-E-A-R.
Oh,
guys
yeah.
use air too?
And H-E-R-E.
H-E-I-R too?
For what?
W-H.
All of
No,
them.
where?
Where? W-E-R-E.
Don't know the
W-E
difference
apostrophe R-E.
People don't know the difference anymore.
Oh, and B-R.
It's because it's a big part of it is because of the tax thing.
I am.
And it's not a big part of it is because of the tax thing because
People
they
that say
use stuff.
AM. I hate
But
when people
it's-
say AM for I apostrophe M.
I know.
Oh my god, that is doing
I'm
something to
good.
me.
I can't tell you.
Trust
I
me.
can't tell you how like my friends and I like we take the pictures of our screen when people send
Oh my
we send
God.
it around each other. Like,
Oh.
You rotten.
No, like
I'm gonna send you a
I
common
am. I
picture.
like I
That's not
have a
business
problem
stuff.
with grammar. I love.
I have a problem with
Um,
grammar, but that's not my business.
I'm
Dog.
fine. I mean, my God, if you're gonna put,
Grammar the problem.
AM.
I would prefer to just say you put I am without the apostrophe then.
Yeah.
If it's that imperative for you to only use two
Exactly.
characters.
Exactly.
the word one time.
Anyhow, I digress.
Yes.
All right, so let's do it. Let's move on to an example.
Mr. Roll me to the next class Friday.
Friday, yes.
You can't do a makeup something, mate. Father knows I can eat that.
The average of
Okay, let's move on. Let's go.
What you want?
Focus, please.
Oh no.
Okay,
You need to
the
be
makers
sick all
of
the
mini
time.
oat cereal.
The makers.
The makers of mini oats cereal. Use an automated filling machine. That can be set at any target fill level.
Fill level
At
at any time of fill level.
Between 12 and 32 ounces. Every box of cereal is not expected. Every box of cereal is not expected. To contain the target weight. But the average of all boxes in that category
But the average.
of all boxes in the category.
should. At the end of each shift, 16 boxes are selected at random. At the end of each shift, 16 boxes are selected at random. And the mean and standard deviation calculated. Based on these sample results, the production control manager determines whether or not the filling machine needs to be calibrated. At the end of a particular shift, when the machine was set, to fill 24-ounce boxes. The mean of the shift production was 24.32 ounces with a standard deviation of 0.7 ounce.
Zero point.
0.7. Part A. At the 5% level of significance, using the critical value approach, assist the production control manager with determining if the machine needs to be calibrated. Okay. All right. So these questions, question like this one, for example, on this exam was worth 20 points.
Oh, Jesus.
Worth 25 points actually. A question like this is designed to take about 10 minutes, right, to answer. So that means that the procedure that we're gonna look at, right, which is not gonna change. The procedure is the procedure. There are 8 steps. You put your 8 steps down. You do your procedure, right? Where the issue comes in is trying to make sure that you set up the scenario correctly, so that you know which one of the HOs and HAs you're going to use, and whether or not those HOs and HAs have any of these problems associated with it. I will tell you now clearly, the only possibility that HO and HA is going to have one of those 3 problems associated with it is whenever it is something other than equal to or not equal to. That can't have a problem associated with it because it either is or it's not, right? But one of the other 2 right, with the ones we call directionalities, right, the one that is testing the left tail or the right tail, they're the ones that can have the problems. They're the ones we have to worry about. Okay? The other one, either it is equal to or it's not equal to. Okay, so they have no directionalities associated with them, therefore they can't have one of those three problems. Now when you look at this question, look at this question carefully, look at every word of this question. There is no place, unless you can tell me where it is, right? There's no place in this question where anybody made a statement. There's no claim made here. Maybe Gregory sees one. Maybe you see a statement somewhere. Maybe you see a claim. Maybe you see something somebody said. But I don't see any. I don't see any, right? So that means then when we start looking at these problems, we need to look at these problems objectively and look at what's going on, right? So what's happening here? What's the issue?
The manager wants to know if he have to recalibrate the serial machine at a 5% level of significance.
Right. So how would he know that? How would he know if he needs to recalibrate the machine?
We'd have to do with HO and HA.
Yeah, but how would he know? What would tell him that the machine needs to be calibrated?
Based on
We find that. We find that.
Doesn't fall within the average.
That if what doesn't fall within the average?
The
5%.
filling
The filling of the cereal
of the cereal
boxes.
boxes.
That the filling of the cereal boxes don't fall within which average?
The 12 to 12.
You see?
Does it have the
12 and
16?
32.
The 16 is supposed
You all
to be-
listen. You all don't look at numbers and try to make those numbers fit your problem. Okay? They only made a very simple statement about this machine, and they said this machine can be set to fill boxes anywhere between 12 and 32 ounces.
Right.
Yeah.
That's all they said about the machine.
Yeah.
The machine can be set to, and then they went on and they told you the machine was set to fill certain boxes today.
It only says
24 ounces.
Okay? They said it was set to fill 24-ounce boxes today.
Yeah.
So if they were set to fill 24-ounce boxes today, that means that what is expected?
That fills 24 ounce boxes.
That the machine
today.
will set 24, will fill boxes at 24 ounces. Even though we know, like the problem said,
That
what?
it can be between 12 and 30.
No, don't forget that.
No,
Oh.
That what?
24.32.
Oh, it's a
If-
standard deviation.
Even though we know what? The problem said, even though
It can
you
be a
do
bit
not
more.
expect any box to have 24 ounces in it, right? Didn't it say that? It said, it says every box of cereal is not expected to contain the target weight, but the average of all boxes in that category should.
Okay.
So that means you choose a box at random, you don't expect that box necessarily to weigh 24 ounces. And you choose another box, you don't expect that box to weigh 24 ounces. But when you take this box, which weighs 23 ounces, and this one which weighs 25 ounces, and you average them, you expect the average of all the boxes produced that day to weigh 24 ounces.
Okay, so if the average does not weigh it, then he would know that he needs to recalibrate.
Right. So, how do we know then? How would he know whether or not the average for that day is 24 ounces or if it's not 24 ounces?
Only by measuring, by recalibrating.
By measuring what? Not
amount of
recalibrating.
I mean, he have to measure the amount of ounces in the box.
Right. So he took, just as the problem said, at the end of each shift, 16 boxes are taken from the shift production, and the average is calculated. The average of this shift production was found to be 24.32 ounces with a standard deviation of 0.7 ounce. So, question here is what? If they expected the machine to fill at an average of 24 ounces today. Now, they didn't go and check every box, right? They didn't go and check every box.
16.
They only checked 16.
Random.
So they're saying I chose 16 at random now, and I found that these 16 actually had an average of 24.32. Does that mean then the machine needs to be calibrated?
Not necessarily,
Why not necessarily?
because it's still 24 ounces being filled, it's just a little bit more.
Right. So, exactly. So that means then that we need to go and test to determine what?
They said they wanted to know what 5% of the recipients.
So it is 16.
What will it do to get it
we
as close to 24 as possible?
If it's equal to 24.
Alright.
Yes. Yes.
Yeah.
We want to know really whether or not the machine really did fill at 24 ounces or not today, based on the fact that we took this sample, and the sample showed an average fill of 24.32. So we would say then, HO and HA, is the mean fill for this shift 24 ounces? Or is the mean fill for this shift not 24 ounces? You see how you have to figure that out. Nobody said it. You have to figure out that this is HO and HA. That if the machine is filling at 24 ounces, okay. If it's not filling at 24 ounces, it needs to be recalibrated. So, machine is filling at target rate. Okay? First step, figure out HO and HA. In the 10 minutes you have to do this problem, this should take you should take 1 minute. You should take 1 minute and figure out HO and HA, because it is the biggest decision you have to make. Everything else, you will see the procedure will be standard. It's not going to change. This is going to cause you grief throughout the problem. Okay? Whenever you said HO and HA, make sure you put a description for what one of those means. You don't have to put both, put one. Okay? So that's step 1, HO and HA. Step 2, what is alpha? What is the level of significance from the test? It said it was 5%. Step 3, we need to choose the test statistic. We need to choose whether or not we're going to use Z or T for this test. Okay? This is why we went through all that foolishness in chapter 8. Because now you need this to be able to run this test. Are we going to use T or Z here? Why?
You're gonna use T?
Are we going to use T or Z for this test?
We have to get the sample.
Okay, because
We're gonna use-
We have a sample of the 16 ounces was the sample.
we have to
Yeah,
standard
but then you want the population.
We have to standard deviation and the population. So,
Yes.
You have the population where?
because it tells you that it was out of
We're using
12
T.
to 22, right?
Why?
Because they say, I guess of the meals, that means they've been around so long.
Listen, you have a simple question to answer. Am I going to use Z or T? Do I know the population standard deviation or do I not?
You do.
The standard deviation that was given to you is for the population or for the sample? Which is it for?
The sample.
Which is it?
It's for the sample.
If it's for the sample, then you have to use T. It's simple as that. Do I know which standard deviation is given?
Right.
Which standard deviation is given? Which one?
7 ounces.
That's a
The
simple
sample.
question. It's for the sample. If it's for the sample, use T. If it gave it to you for the population, use C. Let's not try to make this complicated because it's not. Just one question, answer the question. Okay? So, we found, we can look where it is. It said, based on the sample results, the production control manual wants to determine blah, 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 right? Right, so T.
Okay.
So T then, X bar minus mu over S divided square root of N. So what is X bar for the problem?
The average is 12.22.
What is the average for the sample? What is X bar?
24.
24.32. What is the mean? The population mean expected to be?
24.
And the standard deviation?
0.7.
And the standard deviation was points.
Over.
0.7.
I was saying.
0.7. Oh,
16.
it's P
16.
over 16.
Okay,
Right.
so what does that work out to be?
.83.
1.83. Okay. So, next step is a step 3. Next step, we need the critical value of T. That means we need to know what the value of T is from the distribution based on the alpha and based on the number of degrees of freedom. Okay? So, what is T to the alpha? It's a two-tailed test. I want you guys to stop writing. Okay? What is T for this alpha? This is a two-tailed test. So we know we need to divide this alpha by 2. This, okay? One of the reasons why we went through that whole thing at the beginning, so we could realize, oh, I have to test both sides. So I need this alpha to be split on both sides. So I need to divide this alpha by 2. And then I'm going to use, as usual, the n minus 1 degrees of freedom. So it's a 0.05. So what is T to the 0.05 divided by 2 to the 16 minus 1 degrees of freedom? So this is going to be then T to the 0.025, yeah? To the 15 degrees of freedom. And what is that from the
2.131.
2.131. What's the sign?
Ounces.
What's the sign?
Positive or negative?
Positive and negative.
Yeah.
Careful. Be careful. Positive and negative is both sides of the distribution. So the sign on this, it's got to be positive and negative. You need it on both sides. Okay? So let me number these for you. So that's
And
1,
write that down.
2, 3, 4. So step 5 then. Unlike in chapter 6 and 7, where you didn't have to draw the distribution, now we need to draw the distribution. We're going to draw the distribution, right? Now, we just figured out a critical value of T. This critical value of T are the boundaries. These are the acceptable levels at which we expected this to be. Okay? So, this critical value of T says that, okay, I will accept anything for this within positive 2.131 and negative 2.131. So, anything, as long as this falls somewhere in there, fine. 1.83. So 1.83 falls in there. So, anything that falls in here is fine. So that means that anything that is larger or smaller, we're going to reject.
Yeah.
So that means then that this area in here is going to be the do not
Reject.
reject region.
So we have to write that in.
Yeah.
You don't have to write that in, but these
That's the
rejection
arrows.
things you need to write because they're gonna be the basis for your decision. Okay? So that's step 5. Step 6. You must establish your rule. You must establish your decision rule here. And the decision rule is always gonna be based on, what kind of test you're doing, a one-tailed test or a two-tailed test. The decision rules are not gonna change. The same way you have a two-tailed test, right, left and right, there's a rule for the two-tailed test. Same way you have a left-tailed test, there's a rule for the left-tailed test. Right-tailed test is a rule for the right-tailed test. They're not going to change.
Oh my God.
There are 3 setups for HO and HAs. There are 3 rules for those same HOs and HAs. Okay? So the rule here then for the two-tailed test is simply, well, we're going to reject HO if the T you calculated, if that T you calculated is less than or equal to the negative critical T, which is that, or if it's greater than or equal to the positive critical T, which is that. So reject anything that's smaller than that, or reject anything that's larger than that. Don't reject anything that's within the boundaries. So all these boundaries are saying then is that in a perfect world, I really expect this and that to be the same thing. So anything that falls in here, because there's a standard deviation, there's a standard error, anything that falls in here, I will still accept. Because I don't expect it to be exactly 24, I expect it to be somewhere around 24. So that's the rule. That rule is always going to be with a two-tailed test. Never going to change. You don't have to figure it out. That's the rule. Okay? Step 7, make your decision. And you say, okay, well my decision is then that since the calculated T was 1.83, which is, right, which is more, which is, yes, but which is more than this, right? Which is more than the negative T alpha of negative 2.131. And it's less than the positive T alpha of positive 2.131, then do not reject HO.
All that together. Okay.
Okay, and then step 8. So now we made our decision, right? But now we need to determine what that decision means. Okay, so we decided now we are not going to reject HO. So since we do not reject HO, then we conclude that the machine
Does not need to be.
Does not need to be calibrated.
is filling fine. Does not need to be recalibrated. And company should continue business as usual or operations as usual. So, just so you have an idea of how the grades are distributed on a question like this. This is worth 3, that's worth 2. This is worth nothing because it's given to you. Or if it's not given to you, you use 5%. This is worth 5. This is 3 and 2. 2, 3, 5. That's 5, 10, 15, 20, 25. So you can see very clearly, very easily, where you can very quickly lose points, valuable points. That, right? Very easy to lose valuable points there. And you can clearly see, why I say take a minute and figure this out properly, if you mess this up, this is going to be right. You can still get that right, no problem. But this is going to be wrong. Because if you choose a one-tailed test, this isn't going to be 2.131. This, you're only gonna test one side,
Yeah.
then your rule
Can't
is
get
gonna be
that.
wrong, your decision clearly is gonna be wrong, so your discourse is gonna be wrong. So everything falls on this, you need to take the 60 seconds and figure that out, make sure you get the right one.
But you were saying it's not, if it wasn't given to you.
You wanna see it, you
Fine.
wanna see on,
That's the
Zero
rule,
five.
that's the rule we've been
Rule.
using, yeah. If you know, if it's not, if alpha is not given to you, use 5%. Now that question took us a while, but as we get used to this needs to take you 10 minutes at the very most. Sorry, yeah, three other questions before we leave, so let's. What if Gia is with us?
that's why they record.
I am
Oh,
here.
that- Oh, you are here, okay.
Yeah.
Chime in. Okay, so let's look at this second question. Okay. The Tasty Bakery specializes in Christmas cakes. The Tasty Bakery specializes in Christmas cakes.
Specializes in Christmas.
And uses a recipe that calls for ingredients. And uses a recipe that calls for ingredients. By volume. But the cakes are sold by weight. Calls for ingredients by volume, but the cakes are sold by weight. The bakery's management has kept good records.
Good records, right?
Since they started making Christmas cakes many years ago. The bakery knows that each cake is expected. The bakery knows that each cake is expected. to weigh 48 ounces with a standard deviation of 4 ounces.
Standard deviation of
4 ounces. On a particular day, a batch of 28 cakes. On a particular day, a batch of 28 cakes produced an average weight of 47.2 ounces. For 47.2 ounces. Is there sufficient evidence to conclude at the 5% level of significance? Is there sufficient evidence to conclude at the 5% level of significance that the bakery is meeting its standard?
Sorry, at the 5% level.
Of
Significance.
significance that the bakery is meeting its standards, that's what it says?
Thank you.
Okay.
Hey, Brian, please.
All right, let's go. Let's try to get through this 8 minutes. Okay? What would HO and HAB?
48 ounces and 47.2.
No,
HO and
48.
HA. What are we trying to prove? Look at the question. What are we trying to figure out?
What's
It
happening?
needs to, if their cake is gonna weigh the 48 ounces.
No, 47.2.
So, what are they trying? What is the bakery trying to determine?
The expected weight is 48 ounces. They want to know if the ounces between 40 and 42 ounces is there sufficient evidence to conclude 5% level of significance.
If they
It's
want to
the
find out
standard.
if
The
their
cakes
standards-
weigh,
Right. What is their standard?
48 ounces.
Right. So they're trying to determine if the cakes are meeting the standard of 48 ounces. They already said. We know the cakes are supposed to weigh 48 ounces. So we know what the population mean is expected to be. That's how much we want the cakes to weigh.
40 ounces.
Right? So are these cakes meeting the standard that we made today? The
No.
cakes
No.
we made today is 47.2 ounces. Are they meeting the standard?
No.
How do we know? We don't know. We need to
don't
test.
know.
Oh, sorry.
We need to test. That's the whole point. Because the 47.2 ounces for these 28 they produced today don't mean that the ones they produced
That's
yesterday
true.
were not 48.7.
Yeah.
Right?
Yeah.
So,
Okay.
question is, if on average, are they still meeting the 48 ounces? So, how do we set up HO and HA?
48
So mu
is HO.
equals 48 ounces,
47.
Mu is equal to 48
ounces.
ounces.
and then mu
And
is
then
not equal
not
to 48
to 40
ounces.
Okay, and if it's 48 ounces, what's the caption?
48 ounces, standard weight for cakes.
Machine is full.
No,
cake,
cake weight average.
Cake is producing at a bakery standard.
Cake is expected.
Bakery's meeting its standard?
Yeah, it's a
Yeah.
Say if the cakes weigh 48 ounces,
The
bakery's
bakery
meeting
is
its
standard,
standard.
but yeah, the 48 is the standard.
Okay, bakery cake standard.
So HA shouldn't be 48 also, you have a 40.
Oh, yes, 48. Right. Okay, what is alpha?
0.05.
0.05.
T or Z?
T because it's a
Z.
sample.
Z, Y.
Because it's population.
What is population?
They're using,
You're trying
because
to-
Was
they're
it?
using that's the average of the population that they're using, the 48. 48.
What's the question?
Question asks,
No, what is the question we ask and answer when we're trying to figure out Z or T?
Do we know the
If it's a
population?
sample of the
Population, it's a
population,
sample.
we know sample of population.
do we know the
What?
mean?
The standard
Do we
deviation.
know the population standard deviation or not?
Yes.
Or not.
Right.
How do we know the population standard deviation?
Thinking.
How? Where did they give
just
it?
say the standard
They get it
deviation of
from
4
the
ounces.
records.
Where did they give you the population standard deviation?
They didn't give the
They didn't.
population.
They gave the sample.
Where did they give you the
In the
population?
question.
Where?
They didn't give the population.
They said the bakery is known because they keep good perfect records.
Right.
Yeah, they say the bakery,
Mr. Roland.
the bakery knows that each
Listen,
cake
okay,
is.
he's trying to answer. I'm asking, what is it that you're saying?
Okay, they said that it's expected that the average weight will be 48 and the standard deviation of 4 ounces.
Right, so how do you know that that's the population?
Because this is for the overall records.
That's what they said.
Right.
Exactly, that's what
Okay.
they said, it's for their overall records.
No, I don't
I
have to
tell you
argue
people,
with
you
that.
have to read the question. It's not just did they give you a standard deviation or not, it's what standard deviation did they give you? I keep saying the same
No,
thing.
sorry, I when I read when you were reading it, I picked that out from the beginning.
No, that's fine,
From the
but
total.
it's, right, but you need to associate it
Right.
with whether or not it's the population or the standard, or the sample, so you know that you don't make a crazy silly error here. This is not the place to make it, because,
Yeah, but scripters.
you will choose, yeah, but not only that, if you choose the wrong one here, especially if your sample is small, you are going to have a huge problem. I might notice, to be honest, if the sample is
I
big,
doubt
because
you would notice.
no, I might notice actually if the sample is big because your value for T and Z will be the same thing if the sample is big. But if the sample is small and you choose the wrong one, that's gonna be a problem. So Z then equal to X bar minus mu over sigma divided by the square root of n, since you know sigma. So what is X bar?
X bar is
48.
the 48.
47.2, sorry.
47.2
Minus the 48.
Minus the 48.
minus 48. What's sigma?
The 4 ounces.
Or and what's n?
N is 28. 28.
28. Okay, what does that work out to be?
Negative 1.06.
Negative 1.06, good. So, next then, we're looking at, we need the critical value of Z. So we're looking for Z to the alpha. Do we need to divide alpha by 2?
Just
Yes.
two sides, yes.
So we need to divide alpha by 2. So we're looking for Z to the 0.05 divided by 2. We're looking for Z to the 0.025. What is Z to the 0.025? 1.96. What's the sign?
Plus minus.
Plus or minus.
Plus and minus.
Okay, so plot the distribution. Next. There's mu x bar. So we need plus and minus 1.96 because the distribution is saying I expect this number at 0.025 to be plus or minus 1.96. Don't care what your problem is. This has nothing to do with your problem. This is just from the distribution, right? So plus or minus 1.96 going to be reject in each direction. Negative 1.96, positive 1.96. So we'll plot then the negative 1.06 right here, let's say. Okay. What's the rule?
Do not reject.
What's the rule? Rule.
Reject H.
Reject HO if Z is less than or equal to Z alpha,
Which Z alpha? Which Z?
negative Z alpha,
Negative Z alpha.
or is greater than
Equals to.
or equal to Z alpha.
Positive
Positive Z
Z
alpha.
alpha.
Okay, what's the decision?
Since
is equal to
since the calculated Z
1.96.
Since Z is equal to?
1.96 plus or minus.
No.
since Z is equal to one
Positive?
Positive 1.96.
Negative one
Listen,
point
people,
96.
you've already said, look at the rule. If Z is less than
Oh.
this or greater than this, then what? Reject A Joe, right?
Yes.
What
So
is
since
what is
Z
Z?
is negative 1.06.
0.06.
Yeah, 1.06.
Uh-huh.
Which
Less
is
than.
less than
No,
No, it's actually
it's greater
greater than
Greater
minus
than.
Z
Minus
negative Z
Uh-huh.
equals 1.96.
Negative one
Yeah,
point nine six.
1.96 and
And
Less
less
than.
than, plus or
plus or
minus.
minus.
No,
no.
less than you just did the negative side.
So and less
You just
than
said
the
since
positive.
Z is since this calculated Z is greater than this, and now since calculated Z is less than this. You already did one side, so it can't be plus or minus here. You just did the negative side.
Okay, so minus
Minus.
No plus.
That'd be positive.
1.96.
C,
Plus
C
okay.
alpha.
Since
Z
Z
alpha.
is
Since you
less
were
than
that negative there.
Since Z is a number which is this, which
Uh-huh.
is greater than the negative side, and it is less than the positive
Z.
side, which is
One.
positive 1.96. Then do what?
Do not reject.
And
Do not reject.
Since you do not reject HO, then what?
You can conclude that
The
the
5%.
That the bakery's meeting its
It's standard.
standards of 48 ounces per cake.
they can carry out.
They can continue the baking cake for Christmas.
Okay.
Don't you gotta down that cake.
He's speeding today.
I serious.
After this is 40. And that's it.
Who's speaking today?
Speaking
I can't, it don't make no
Can't
sense
you
right
go
now.
fast?
But yeah, by the time he come back, he can face us off.
You right? Me tell me
I
again.
don't make no sense.
You lie.
I went to service.
Paper. I have some paper.
No, I made my book then.
Me too.
I don't want to fancy.
He said, if you get the baby sample.
Man, I thought population men when you're dealing with people and stuff.
That's what they do.
I appreciate.
Yeah, I thought
I
that
was so
was
comfortable.
Okay. So when you guys are doing this right, and this when you use this rule, you know, and here is the do not reject region, right? The do not reject region. If you wanted to say here, since Z falls in the do not reject region, do not reject, you could say that. You could say that. I would look at your paper with scorn, but it would be right.
Why would you look at it with score?
Because you chose the
Because you
easy
just
way
chose
out.
this easy. It falls in the do not reject region, so do not reject it.
You have to say it's sophisticated.
That's not sexy.
I know you like,
But
I know
Mr. Rowe, come on, man.
Isn't it sexy?
That multinational man
you
is.
like sexy stuff.
Since Z falls in do not reject region, do not reject it.
Are we doing a singular
That's
sign?
what a
Right.
statistician
Are
should
we-
say,
are we
but
doing the
it would be
right
right.
So we can say just do not reject since he is.
You say it ain't sexy, don't
It's not
say it.
sexy, but you can see that. I would just look at,
You might take off a
Scorn.
minus point because.
I won't get no
Scorn them.
points. I would just be disappointed, but it would be right.
I don't know the time.
Okay, question.
Okay, let's move on. Oh, you have a question?
We're gonna do a singular one?
Well, yeah, let's move on.
Let's see myself.
I'm gonna be seeing you after that. You first, hurry up, get out of the way. Yes, I got ready.
Okay, let's do this. So two to do, sir. The Bureau of Labor Statistics reported that the average yearly income for dentists
Thanks.
in 2009 was $110,000 per annum.
100 and
$10,000 per annum.
A sample of 81 dentists was taken in 2010.
you said 2001, right?
2010. Breathe.
Revealed an average yearly income of $120,000 per annum. On average yearly income of $120,000. The Bureau knows that the standard deviation of dentists' income is $36,000. We want to determine if there has been a significant increase in dentist income since 2009. Use the 95% confidence to test this hypothesis. Okay. All right. So, what are they trying to accomplish? What's the scenario?
They wanna know if it increased,
There's
the income increased.
If the income has increased, right, from one year to the next, so what would HO and HA be?
One hundred ten thousand.
equals
110,000.
What? HO is 110,000?
Yeah.
10,000.
I think 110,000.
What?
Because 110,000
Dollars.
is the range,
The
right?
range.
It was in 2009
What are you asking me?
previously.
What are you asking me to write here?
Oh,
We need to go on that first.
No, we wanna know,
Mu
we wanna know
equals
if it's
mu.
36,000.
If mu is greater than 100,
And when
You
you
is
know what's the
greater than
decrease in it?
100
Or
was
the
equal
increase in
to
it?
10,000.
110,000. It's greater than or equal to 110,000.
Uh-huh.
And then HA would be mu is less
Less
than
than
or equal to.
No, just less than 110,000.
And what's the caption you're gonna use?
It was a percent. But we're
But
gonna use 5 if they give us a big.
What caption?
No, wait,
what
wait, we
caption
saying-
are we going to use?
Oh, the increase.
2009.
That there has been.
Which one are we putting it on?
On the HO,
So what is it gonna say?
increase in salaries, dentist increase in salaries. Since
Dental
2009.
salary
So dental salary has increased?
Since
Salary
2009.
increase.
Good with that? Okay, where do we go?
Alpha.
Mm-hmm.
Alpha equals.
0.05.
95 is they give us less.
No,
Or is it 5 because of
95%.
95?
I give it to you.
They
I
gave
gave you
95%,
95%.
100 minus 95, gives you 5%.
Okay, are we happy?
Yes.
We are? Okay. I'm not happy because this is not right.
That ain't right?
It's the bottom one, eh?
Well, it can't just be the bottom one. If one's wrong, the other one has to be wrong. One can't be wrong, and the other one has to be wrong.
Well, I
It
think
was
the first
120.
line right, because we wanna know
No,
if it
we want
increased from
120.
110,000.
So 120.
New one.
But the new one is the new yearly salary that just came out, so we should go based on that one.
No.
The 120?
No. Look at what the question said. Has the salary increased?
It did.
So it can increase if you're using,
Since
if you're testing it
2009.
against. But if you're testing it against the increase, you can increase. $120,000 can be more than $120,000. So clearly you have to use the 110.
Because it was from 2009.
Right.
Yeah.
But because you guys refuse to follow rules and refuse to listen to me, you don't pick up on these things. I said you have to look at the scenario and you have to look at every word. And this question said, what did they say? They want to know, has there been a significant
Yeah, I was thinking that, but I
increase?
think about the
I said
diagram or
significant.
less.
I said significant.
So saying significant means to
It's
do
an
what?
extreme
It's extreme
discretionality.
directionality.
Mhm.
So it's extreme directionality, which means this needs to swap. Because now you need to put in the HA what you want to test.
Yeah.
Oh.
Because you know what would have happened on your exam?
Wrong.
X. That would have been a big X, and
With
everything else
oh
would have
no
been
and a
wrong,
what?
except if you got your TOC right. Because that's going to be independent of everything else, right? TOC is TOC, whatever you calculate. All this other stuff would fall wrong from that because it would be on the wrong side.
Yeah.
So TOC.
Hold on a second, I try and read the shoe.
So
Yeah,
So
actually
the
this
first
has to
piece
be
we
the other.
changing that, eh?
This has to go down.
Yeah,
That's
gonna
what-
be mixed up.
That's what I was trying to say.
TOC.
These guys get this population sample mixed up.
Using
But I'm
T.
taking the
T.
sample because
T.
they use
A sample of
2009.
No. Look at the question. You will refuse to read the questions. Refuse to read it.
Repeat. A sample of 81 dentists was taken to
They gave us the,
Sample?
no, they gave us the standard.
The standard deviation is from the population.
Because they said what?
They know.
Because
That
they
the
said they
Bureau
know
knows
that
the
the
standard
standard,
deviation is
so it's from the
$36,000.
population.
If you are
not the
refusing to follow the
sampling.
rule, you can get it wrong. The
So
rule
he
is
was
very
using-
simple. It has to be Z. You
Yeah.
know the population standard deviation, so it's Z.
Yeah.
So what is X bar then?
Uh-huh. 120 minus 110.
36,000.
36,000.
81.
So what's that equal? No.
Okay, so the wrong one.
Yeah, something you do.
2.5.
2.5. Okay. So, C, so we're looking for Z versus then, so we're looking for Z to the alpha. Do we need to divide alpha by 2?
Yeah.
No, we tested one side.
No, just one side.
Just one
So
side.
Z to the alpha then, so the Z to the 0.05. So Z to the 0.05 is what?
What page that is?
Page 304.
What is C to the 0.05?
0.025.
What is C?
Point zero,
Oh,
point
the
zero
zero.
one nine.
It's a
1.96.
Go to your table.
2.575.
No, wait,
No.
are you guys getting these numbers?
1.645.
1.645.
Oh.
What's the sign?
That on 304.
Plus
Plus and
and
minus.
minus.
I looked at the wrong thing.
What's the
Plus.
sign?
It's
Minus. Plus.
No, no.
It can't be
What
plus or minus, because
is
it's on one
The
side.
sign.
Plus.
Plus.
Positive.
We're testing the left hand
Left
side,
hand
right?
side, yeah.
I mean, sorry, we're testing the right
Right
hand
hand
side.
side.
Because we said we wanted, we said we wanted to make them prove to us that it's greater than 110, so we're testing the right hand side,
Oh, Jesus.
right?
Yes.
So it has to be positive. So 1.645, and that has to be positive. Okay? Plot your distribution.
So you said put the minus sign there, that's good.
Oh, sorry, yes,
Yeah.
you're right, thanks. Plot the distribution, so here is mu, x bar. So the boundary is now positive, 1.645. So it's saying anything then that's too far that way is gonna be rejected. So the calculated value is 250.
Rejected.
So what's the rule?
Reject HA.
We're never rejecting H.
Oh, reject HO. If C is greater than positive, it is what? Z bar. I mean, what is alpha? C alpha.
What am I writing? What is greater than what?
It's greater than
2.5.
If it's greater than
plus
positive,
positive.
C alpha.
Positive C alpha.
Said Z equals 2.50, which is greater than positive C alpha equal to 1.645. We reject.
Reject H. Good.
Says we reject HO. That means that the dentist salary, or am I saying it correct?
Mm-hmm.
Okay,
Has
has
not
not
increased.
improved. It not increased since 2009.
No.
Oh,
No, it's just, it's not
You
increased.
rejected HO. You
Okay.
rejected HO. So that you rejected HO, you means you're agreeing with this.
Okay.
And this says that
Decrease.
dentist salary has increased.
Decreased. Yeah.
So it has, the
It has
average
increased.
dentist
Not
salary
significantly.
has
Not
increased.
significantly.
Yes. it
Has
is.
Okay, it has increased, okay.
The average dentist salary has increased.
Increased.
Has significantly.
Significantly
Increased.
increased. So what would you say to the dentist?
Can't pay too much.
Keep cleaning people teeth.
Or you should say something like, since we rejected HO, the average dentist salary has increased, students should be encouraged.
To study dentistry.
dentistry.
Oh, Jesus.
There is good income to be made.
So we're looking for-
Listen, this is worth 5% of your grade, of the grade. So you have to decide how much you want.
No, I
to
mean,
put.
what if you just say to study dentistry, is that enough or?
Maybe, it could be. I mean, you know, how much of a case you want to make to what you think.
Okay.
This is what you're giving a recommendation here,
Right.
right? So there's no magic amount. I mean,
Excuse me.
oh, we left off the equal sign. That should be C is greater than or equal to CL. Okay.
Mr. Rose,
Aye.
can you tell me why you put the negative sign underneath just top?
Say that again.
Can you explain why you put the negative sign there just top?
That's the rule. You been here?
Yeah.
Yeah, that's the rule. The,
Is it equal to?
That's
yeah.
equal to sign.
She called
not
it
negative.
Oh no, it's not a negative sign. It's greater than or equal to. That says it reject HO if Z is greater than or equal to Z critical. You get that? Hello?
Okay, so this, all right. This sign, which you're rejecting in this rule number 6, this is referring to which one in number 1?
That has nothing to do with number 1.
Okay, so
This sign has nothing to do with number 1. This
Okay.
sign has to do with
The result.
this sign has to do with this, with number 4 and 5 in comparison to number 3. You see? We know that the null is going to be rejected only if the null is too big. Sorry, only if the Z is too big. So what we're trying to test here is to determine whether or not this calculated value of Z is too big compared to this. Because in a perfect world, the Z you calculate and the critical value of Z from 4 should be the same thing. So when we look at them on the chart is saying, I will accept any value of Z up to this blue line. Anything to the left, anything to the up to and to the left of this blue line is fine. Anything this way is too big. So all this rule is saying is, all this rule is doing is verbalizing that. They're the same thing, right? Gia?
I get it, thanks.
Yeah. Okay, so let's look at this last example before I hand out your cases and then you can be out of here. Automobiles manufactured by the Efficiency Company.
You said manufactured by.
By the Elkin Company.
By the what?
By the efficiency company.
Have been averaging 42 miles per gallon. Have been averaging 42 miles per gallon. In highway driving. It is believed that its new automobiles will average more than 42 miles per gallon. An independent testing service road tested 36 of the new automobiles. The sample showed an average of 42.8 The sample showed an average of 42.8 miles per gallon. With a standard deviation of 1.2 miles per gallon.
1.2 miles per gallon.
At the 5% level of significance, test to determine if the new automobiles actually do average more than 42 miles per gallon.
HOHA. Bring it down equal to the 42.
Okay, sorry, what did you say?
HO is mu is greater than or equal to 42 miles per hour.
M miles per gallon?
Per gallon.
Per gallon, yeah. And HA is mu less than 42 miles per gallon.
Okay.
Okay, I mean,
You agree?
If I may,
Anybody disagrees?
I
with this?
disagree.
Who's saying?
Gio.
Oh, hi, Gio. Who is talking?
Like, signs should be flipped around.
Why?
No.
Because
they
I
don't
guess
say-
I just read this based on the last sample that we did,
Uh-huh,
example that we did.
right. Right, but based on the last example that we did, what was the scenario there that made that?
A salary increase.
it's a significance.
They said, right, a significant salary increase, so.
They say significance to tax.
This is an extreme
It's an extreme
direction.
So,
That's right.
Say will average more than 42.
So Gia, you wanna change it?
HO is supposed to be.
Okay, let me ask you,
direct.
let me make sure I write the right number down. I have, you said if you believe that the automobile average more than 32 miles per gallon, you did say 32, right?
42.
No, I mean the second number you said. I may have heard you wrong.
Oh, no, the second number from the sample,
Independent testing
It's still
is
42.
42.8.
it says, it is believed
Yeah.
that its new automobiles average more than 42 miles per gallon.
Oh, I wrote 32, I'm sorry.
Okay. Okay, so, anybody? So did you want to change it or leave it?
I
What's your-
know, I know, but sorry.
Okay. Anybody disagrees with that?
sound like I go.
No? You're okay.
Testing.
Oh, Jesus. I think HA is supposed to be the max weight
Why? So you wanna
because it's more.
put HA?
Yeah, I think.
Like
But then it's saying,
Yeah.
and then
So everybody
actually
feel like that?
42 or more.
So you're saying you're saying what I put in green?
Yeah.
Oh, just hold on.
Yeah, because HA is
There's more than, so it needs to go,
I would switch it
it
to
needs to go to the
green,
left.
to me.
Cause if you say at least, it'll be to the. Right in the bit. It says believe that a new
think it's
automobile
supposed to be the way
built
of
more
the
than
The average is,
42%.
average is more, is 42 miles.
42 miles per gallon.
it's more than 42 miles.
It's supposed to be
They
the
should be
green.
reading their own thing. They should be reading their own thing. I don't know what they're reading because it
It
says,
says it is believed
right?
To be more.
its new automobiles will average more.
More
That's the
than-
belief.
Right.
Right.
They
So
said
that's
it
what
is 42 miles the first time.
It's
That's it
more
from-
than.
No, they never said
Averaging
anything.
42 miles.
Averaging
Average.
42
Averaging.
miles.
That's
The
the
automobiles that manufactured by efficiency company
And
have been averaging 42 miles per gallon of gasoline.
They have been doing
And it is right, and it is believed that the new automobiles will average more than 42 miles per gallon.
Right. So we talk about the new automobiles.
Yeah,
Because
not the.
well, they said with a 5% level significance using tests to determine if the new automobiles are averaging more than 42 miles per gallon.
Right. So that's why.
Yeah.
Just saying
More
right,
than.
I mean right. Which one is right? What are we trying? What are we doing?
HA should be.
Guys, I still think,
I think it's the green.
Hold on, Gia. Okay, Gia, what are you saying?
I still think switch it.
You stick with the green?
I think so.
Yeah, I go with the green.
You're going with the
Me
green.
too.
Great.
Lies.
Like here in the original black.
You're going the original black.
Yeah.
So Gia, why are you choosing green?
I changed mine yet.
Sometimes I hear more than.
I can tell you why. It's the green.
Okay. Why are you choosing green?
Because we don't do each sample of each one. So we are the last one.
Can't take it.
No,
because
I
we
know,
tested
I was
more
based
than.
on yes.
Huh?
I'm saying
Why?
more than, it says here.
Why are we testing? But why are we testing the more than then?
Because it's the newer automobile.
And
And we're just
We need to
proving
test
that
it
the
out.
other one is not
Independent.
more than.
Yeah,
We need to prove the
and you guys refuse to follow rules.
Oh, jeez.
This is a research hypothesis. This company is bringing out a set of new cars that haven't even hit the market yet.
Right.
Only them have the data. Only them know anything about this 42 miles per gallon that they're saying is what they're gonna average
Nobody
more
can
than.
refute them.
So nobody can refute them.
Yeah.
So you
Right.
have to make them prove it. You have to put what they're saying in the alternative. That's why. If you're right, who's saying green is right? But it's the reason why. Now, if you
But I say it too, and I say you have to prove the
What
opposite
you
of what
say
they
is you have to
said.
prove why.
why?
Because like you said, they already said they're doing 42 gallons per hour, so you gotta see if anything fall in the range.
Yes, but what is the reason why? you're
Because they are the
choosing that?
manufacturers and no one else.
Because
Right,
it's
it's
research.
because
It can't be
it's the
refuted by them.
manufacturer. It's the manufacturer conducting this hypothesis test. Even though they hired somebody independent to come in and do it, they have the data.
It's still their data.
It's their data,
It's a
right.
independent
One
person.
is
It's
media, the second one is
That's
real.
true, yeah. And then call it research.
So yeah, so it's one is
Media, extreme, and research.
Yeah.
Okay, switch it on. HO and HA is done finally, so what are we gonna say for the caption? Now whenever we do the directional tests, like this, it doesn't really matter which one of these you put, you can always put it on either one, but the rule, the convention usually is when you do the directional test, to put it on HA, okay? Because that's usually the thing you're testing, really. So, we'll say, autos average more than 42 mpg. Okay, what is alpha?
0.2.
0.05.
Okay, T or Z?
T because it's a sample.
It's a sample of their own.
Sample.
Do you know population standard deviation?
No,
No.
because it's a sample.
So T is equal to x bar minus mu over s divided by square root of n.
And
Thank God.
So what is x bar?
42
42.8
42.8.
minus 42
divided
over
by
1.2 square root of
36.
36.
Okay, what is that?
Four.
Okay, so for the critical value then, we're looking for t to the 0.05. Well, t to the alpha, do we need to do anything with this alpha?
No.
No. Do anything?
Oh, it's a one tail.
It's one tail, so t to the alpha, n minus 1 degrees of freedom. So t to the 0.05. How many degrees of freedom? 35? So what is t to the 0.05, 35 degrees of freedom?
1.69.
1 point,
69.
what's the sign?
Plus.
Positive, since we're testing that side.
Right.
Yeah. So plot distribution. Ux bar. The boundary is at 1.690. Gonna reject everything that way. Calculated value came in at 4, which is all the way over here.
So
So what's the rule?
reject HO. T
Greater than.
Greater than or equal to.
Yeah.
T.
What's the decision?
since T is
Since T is equal
1
to
point, no, I mean 4.00.
Uh-huh.
which is rated at
Right.
positive T bar.
You can call this thing T bar.
uh,
T
T
alpha.
my bad,
T alpha.
Uh-huh.
which is equal to
Equal to
1.690.
1.690.
We reject.
Reject.
Okay.
HO.
And H, since we reject HO,
Then we reject H. Oh.
We can conclude that the
Then the
new
answer.
the average new automobiles will not.
No,
No,
build.
that the new-
Build. That it build.
okay, we're rejecting HO, right? So we're concluding that
That
They
the new
will
automobiles will
Yeah,
average
more
more
than
than
42
42 miles per gallon.
Okay, per gallon.
So the company can continue
Manufacturing.
producing the newer
Same vehicles.
automobiles.
I would say the company can
Upgrade.
move on, because remember they haven't put them out yet.
Right.
So they can move on with their plans
Or
to go
feel
ahead
comfortable in producing the
Right.
new,
So
something like that.
they proceed with
Yeah.
their plans,
To
with distribution, their plans to roll out or distribute the new automobiles, the new, you can say more efficient if you want to, just to make it sexy, you know?
right, right.
Sexy.
That's not like that.
Do you remember you guys now to the point where at this stage, we're at the stage where we look at ourselves as if people have hired us to do this, to give them this recommendation, to do these tests and give them and recommend to them what they should do. So you want to give them something. Don't just say, here's your test. Yes, it seems like they're producing more than, going more than 42 miles per gallon. So yeah, you should feel comfortable to go out and do it. This case is due at the final exam.
Mr. Williams last Friday.
Mr. Willis, keep going to class on Friday, we can get our other tests back.
Which
Want
other
it?
tests?
The one we did today.
If they're ready. Sure. Of course I'll give them back to you. Yes.
Okay, and then the test is the following Saturday,
Yes.
final exam.
Okay. I used to change my
That's it, Mr. Rowe?
That's it.
Dairy Queen has been
Oh, I hope you know. I hope you're ready to take these and get back. Kiro, that does not exclude you.
I'm just thinking, man.
I just want to give you guys the format of this case before you go, please. Some layout. This apparently you guys don't get a chance to do cases in many classes.
Why am I working right now? Should the school close at 12. Are you serious? It's so quick to drop the
All right. So we're gonna use, to lay out this case, we're gonna use the journal style case management layout. I mean, there are many different styles, but you know, I don't like loose layouts, so I want to make sure we have a very tight thing, because I'm going to be looking at, we're going to be looking for specific things within certain sections of the case. This case is not very long, and the data is given, so I don't expect that it'll take more than maybe 3 pages for the case write-up. So typically in the academic or in the journal layout, typically you'll have an abstract, but I'm going to waive the abstract next. This case is very short. Okay, so we'll leave that out. Then you have the introduction. So you have the methodology. Then we have the analysis. And documentation. Okay. So we have so like so we'll waive the abstract, so no abstract necessary for the case. If you were to look at sort of the grade distribution for these, this is gonna be about 60% the analysis. Introduction will be like 5, methodology and data collection will be about 15 plus 80, and then these two together will be like 10 and 10. Yeah. So, introductions, and I find this all the time, this is where people get very creative. Introductions are not supposed to be a summary of your case, okay? This introduction is supposed to be a description of what the issues are, how you plan to address the issue, where you got the data. It's supposed to be really, it's not a description, it's not a summary of that piece of paper. Your introduction is supposed to be an overall description of what the problem is and what you plan to do to solve it. Okay? So sometimes in the introduction, people will say, if you look at, you guys should go online, look at some academic papers, look at the way some academic cases are laid out, look at the language, right? In this study or in this paper, we will describe blah 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 what Thorndike's problem is. Then we will look at solving it in a blah blah way. And then we gave recommendations on how to make their process more efficient, blah blah, whatever it is. The methodology of the data collection. Where did the data come from? Did you go out and conduct surveys, or was it provided to you by the manufacturer? Was it provided to you by the customer? What did you do with it? How did you organize it? Right? That's what happened. What has to happen in here. Then the analysis is now, what did you do with the data? How did you use it? What techniques did you use to solve the problem? Are you going to use sampling and sampling distributions from chapter 7? Are you going to use confidence intervals from chapter 8? Are you going to use hypothesis testing from chapter 9? Are you going to use a combination of those things? Are you going back to chapter 3 to analyze the data first and then find the means and all that stuff? All of that needs to be culminated here, which is why it's 60%. So the smart person, in my opinion anyway, would look at the data and start compiling a whole gamut of things from chapter 3, because you need to analyze the data. You're going to need means and standard deviations and whatnot, so you're going to talk about that. But what I do not want in the case write-up is any calculations. I don't want to see how you calculated the mean and the standard deviation. I don't want to see how you calculated Z's and where you got this from and that. All that should be done in an appendix to the paper. If you want to show it to me, it's up to you if you want to show it to me, but I suggest you show it, but you provide it in an appendix, right? Use Excel or something to do your analysis. To do your calculations for standard deviation and mean. Don't sit there with a calculator and do it. Store it in Excel and calculate it. Then the recommendation will be, should these people buy this machine? Should they not buy this machine? If they do buy, why should they buy it? What does it do to their operation? And then the conclusion is just an overall sort of indication of what I have done. So the introduction is what I plan to do, and the conclusion is what I have done, right? Because the conclusion will include what recommendations you put forward. If you plan to use any additional sources, like if you plan to use your textbook, and you plan to use your textbooks, and you plan to go online and get additional information about these things are rackets. These people produce rackets. If you plan to find out, I don't know anything about rackets. I don't know what rackets are made out of. I don't know how rackets are strung and stuff. So if you plan to use that kind of information from online, make sure you cite these things in the paper at the back. Just use footnotes, the footnotes of where you got the information from. So we don't have any intellectual property issues there. And that's pretty much it. Like I said, about 3 pages, single space for the case write-up itself. 1-inch margins, no folders needed. One single staple in the upper left-hand corner of the paper. When you do the appendix also needs to be typed. Don't hand anything into me handwritten. Make sure everything is. That's why I say throw it in Excel. So you just have the data back, etc. this is also being used as a learning exercise. So there are a number of like curve builders online you can use if you want to draw your own normal distribution. There's a number of curve builders. Go online and Google curve, normal distribution curve builders or something, or use Excel or use Minitab. Just put the data in and ask it for the curve, and it'll do all that. This is supposed to be learning, so it also shows you what some of the software can do. So, and if you want to send me, like this is due at the final, so if you want to send me drafts of it as you go along, do that. And don't wait until the day before to send me a draft and say, oh, here's my draft and I need this back now, because that ain't gonna happen. So, you send me something, give me maybe a day or so to get back to you with it.
Mr. Bull,
Hi.
okay, maybe I missed something, but what is this for?
What is this for?
Yeah.
This is your 10% paper?
Oh, I wasn't aware I had to write a paper.
Oh, well, I guess you missed that.
Yeah, I know I missed a lot of things, so that's not.
Yeah, I guess you missed that. Yeah, we talked about that in the first class.
Yeah, I missed that as well.
So what is the paper on? I see a breakdown, but I mean, what am I writing on?
You're gonna get it's a case. So I guess the office will send you the case.
Okay.
All right. Any questions?
How much is the final exam review?
30.
You're gonna let us know next week when you're going in, right?
If you need it.
I need it, please.
I need it.
I will give you
That's it?
Yes, that's it.
So you said back today on the.
Stay back. What do you need?
I made an attempt one.
I was getting confused, like, when we had to choose these
Come on.
or F.
Come on.
Simple as
Well, that's any of your question?
I made an attempt on
What
it.
is that?
It's the homework that was.
Oh, shoot, I forgot my homework.
I made an attempt. I tried. Somebody didn't understand.
Like,
I started like some
when we choose VMT, I know we have to read and see the questions. And I noticed with this one, we have the population.
I finished it, but I still
I
haven't.
started, but this one just gave a sample. It also gave the standard deviation, but not a population deviation. So if it was the population standard deviation, then it would be C. But it just gave me a sample with a deviation, but not the popular deviation.
Yes, that's what's
Early on,
I don't have practice because I didn't.
You just need to figure out the question. You have to read enough, you can do enough of them so that you can see how the way the questions usually structured, where they give you the standard deviation. Did they give it to me with the sample? Did they give it to me with the population? They're always going to give it to you somewhere.
The standard deviation would be in both. One would be with the population and one would be the sample.
Right.
The one with the sample would be with T and the one with the population would be with C.
Now, clearly, like this question you just had on the exam, where it didn't give you a standard deviation at all, you had to calculate it. So clearly you had to use T, because nothing was given to you.
That's what I did, but I still get lost. I used T too.
I missed a lot.
I used T and I was No, I used T.
I use P.
So I used T? I used T.
I use P and Z. It depends. I use one without a population.
Hey,
Population.
we got a
and
link
then
for this
Z.
case, Christia.
Oh, that's
You need the link? Oh, easy. You got it.
You got a link early, so if you want to go out when you come to that, that'll be really right.
I don't know what the hell it is.
Anything else?
I mean,
I guess when I look it up.
I just gonna practice myself.
Yeah,
But
this section in particular, you need
this is
to,
a
there's
lot.
lots of practicing. This,
Hypothesis that
Mr.
So,
Roll,
sir,
Yeah, class, Miss.
Mr. Roll, yeah, like the stuff you give us be easier to do than in the phone. Hey, I know, okay?
we have class.
that's not the number for the.
Okay. Class next week. No, your quiz next week.
no, we're not gonna put this.
No quiz next week.
Jesus.
So what are we doing?
Just
Well, anyway, I have vacation this week, so I could come, so.
So next week is the quiz.
Next week is
No,
chapter 14.
that's
or-
last class.
We're gonna do we can spend an hour on chapter 14, because it's just
We have
it's
class
one very
Friday?
specific thing.
You do have class Friday?
So we can do
So,
revision.
Mr. Rose.
Chapter 14 is what?
We do
On
revision.
Saturday.
Alright, if anything, I'll just see.
Oh no, wait, I thought the finals the week after next.
Finally,
On the 12th.
These people said that at least 5 times today. The final
I was
times of the
listening to
drought.
them.
I had to, and then this paper, I had to find someone who did this before, so I could see how to steps to follow, because I ain't lost it anyway, I ain't read yet.
We're
Well,
doing
people
always
I know
declare
who did
being
this
lost
before
before we do it.
are back
Yeah, I
in
know,
here.
right?
Hey, look, girl. All the people I know who did this before are back in here. It looks like I could be the same way next summer.
Yeah, just again, I used to.
Stuff like a do-over.
The best thing to do is practice on your own, practice on your own, practice on your own, that's it.
That's the thing that was nice. You do the same one question.
That's what I've been doing over and over, and trying to read it, understand it, know what to use and what not to use. Okay.
Your CLB class is also going to be doing with you this week, right, sir?
My COB class?
I'm so what I'm
Then what?
The students, they can be doing chapter 14 next week.
They will finish chapter 14.
So what do you think?
Nothing, they do nothing, because I see we go.
They're doing reviews.
Good,
Review.
I'll be there.
Are you supposed to be there last week, huh? Did
I
you go?
went.
You wouldn't know what happened.
I did go.
Did you enjoy?
No, because the stupid office people are retarded. And the fat woman and the fat man who was sitting down in the corner, I would walk over the whole T block, B block
Just
building.
me.
And how
Just
come Miss
me.
Ariaki don't know where you work?
Yeah.
And she's the head of the department.
She said she's in math department.
Yeah, so what happened? Why she didn't know where you work?
She doesn't work in the business school.
Oh, because I went to the T block, then I went to
The
the
B
B
block,
block.
E10.
No, I went to the B block first, and I couldn't find the class. We knock on everybody's door.
Yeah, it's a good thing I had your number.
Who has your number? She has your number?
Oh, baby. Baby.
I'll be there, Mark. Come into your big classes. I'll see you.
How you doing?
Okay.